Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the New York Regents Geometry Common Core exam for June 2015. All right, let's take a look at number 6. Number 6 reads, which figure can have the same cross-section as a sphere? Now, a quick reminder is that the cross-section of a geometric solid is the intersection of that solid and a plane. All right, the steps we're going to use for this problem are as follows. First of all, we're going to sketch a sphere to give us a visual. Then we'll find the cross-section of the sphere. After that, we're going to determine the cross-section of these four geometric solids and see which one matches with that of the sphere. All right, so let's go ahead and sketch a sphere. A sphere is just like a ball. So let's say that's the sphere right there. Now, this is a 3D object, okay? It's not just a circle, so it's a 3D object. Now, to determine what the cross-section is, what I'll have to do is I'll slice this sphere with a plane. Okay, imagine playing Fruit Ninja, for example. If you're playing Fruit Ninja and this is an orange and you slice it with your katana, what kind of outline will be formed when you slice your orange with your sword? Okay, so that's what we're going to be doing. So if we slice this sphere with a plane, the outline of the intersection gives us what the cross section is. If we do that, what we're going to have is we're going to have a circular. Let me draw that again. A circular cross section. Okay, so if you cut an orange in half and you look at it from the top, what you have is a circular cross section. So that is the cross section of a sphere. All right, so let's go ahead and sketch the plane. So this is a plane right here that intersects the sphere. Okay, so when the plane intersects the sphere or cuts the sphere, what kind of outline is formed? That's what we're talking about here. So this outline is a circular outline. So this figure basically shows us that the cross-section of a sphere is a circle. Okay, so let's go ahead and write this down. From our sketch, we can see that the cross-section, the intersection of a plane and a sphere is a circle. Okay? Another way you can think about it is if you take a torch and you flash it from the top of this circle, what kind of you flash it on this sphere, what kind of shadow will be formed on the ground? Okay, that will give you an idea of what the cross section is. So if you take a torch and you flash it from the top right here, you shine it on the sphere, you will have a circular shadow because that's basically what the cross section is. It's going to be a circular cross section. That's just another way of looking at cross section, projecting a shape onto a plane. Okay, so now that we know what the cross section of a sphere is, a circle, we're going to look at these four solids we have right here, and then we're going to determine what their cross sections are. Now, the easiest way to determine the cross-section of these solids is by simply looking at the shape of the base, okay? Because the base is practically resting on a plane. I don't need to cut it. So if you look at the base of this shape right here, this rectangular prism, its cross-section is a rectangle, okay? It's a rectangle. And then if you look at this square pyramid right here, what is the cross-section? Look at the shape of the base. That tells you what will happen if you slice this shape with a plane, because it will create a shape that's basically similar to this in appearance. So this one looks like as a quadrilateral. I don't know if it's a square for sure because there are no measurements here. So we have a quadrilateral as the cross section here. And then here, look at the shape of the base. What do you have? You have a circle for the cone as the cross section. If you slice this cone with a plane, you will also have a circular outline. If you look at this truncated prism, look at the shape of the base. What kind of cross section is that? That is a rectangle. Okay, so which of these is the answer? Well, the answer is clearly option number 2 because it has exactly the same cross section as a sphere. The cross section is a circle. All right, let's take a look at problem number 7. It reads, a shipping container is in the shape of a right rectangular prism with a length of 12 feet and a width of 8.5 feet and a height of 4 feet. The container is completely filled with contents that weigh, on average, 0.25 pounds per cubic foot. What is the weight in pounds of the contents in the container? Now, one thing you want to note in this problem or problems like this is that to find the total weight of a solid, you simply multiply the unit weight by its volume. Okay, so in this problem, these are the steps we're going to follow. First of all, we're going to write down the formula we just talked about that relates to total weight as being equal to the unit weight times volume. We're going to find the volume of the solid since we do not know what that is. And then we're going to use that result and the unit weight which is provided to find the actual weight of the shipping container. All right. Okay, so let's go ahead and start with step number 1. So for step 1, let's write down our formula that's going to guide our problem solving process. So the total weight of our solid is going to be equal to unit weight multiplied by what? The volume. Okay? All right, so step 2, we want to find the volume of our solid. What is our solid? It's a right rectangular prism. Okay, so what is the volume of a right rectangular prism? The volume of a right rectangular prism is length times width times the perpendicular height. Okay, so this is a nice problem here because we're provided with the length, the width, and the height, so we just basically multiply them. So since L is 12, W is 8.5, and the height H is 4, we'll simply plug it into this volume formula to compute what the value of the volume is. So V is equal to 12 times 8.5 times 4. Okay? All right, so let's compute that with our TI 83 plus. So 12 times 8.5 times 4. And then we get 408. So the volume of a solid is 408 cubic feet. Okay, so 408 feet cubed. Now, is our answer option number 2? The answer is no. Okay, you have to be careful here. This is a very good trap. It's getting students who do not finish the problem. This question doesn't ask for the volume of the solid, it asks for the total weight. Okay, remember we have a formula up here in step 1. The total weight is the unit weight times the volume. We have just found the volume, and we know what the unit weight is. The unit weight is 0.25 pounds per cubic foot. So something per cubic foot tells you the unit weight, okay? So that's why you have per cubic foot, just 1 foot. So let's write down what we have. So we know that the volume is 408, sorry about that, 408 cubic foot. All right, and we know the unit weight. The unit weight is 0.25 pounds. So for every cubic foot, you have 0.25 pounds. Okay. Now, what is the weight of the solid? We just combine these two pieces of information. put them into this formula that we have already established right there, and that should tell us what the total weight is, okay? So total weight is going to be unit weight, which is 0.25 or 1/4 times 408. Okay, and it's just as simple as dividing this by 4. If you do that, you end up with 102. So 102, if you multiply these two, you're looking at weight, so it's pound because the cubic foot here and this cubic foot cancel out, so you just have pounds. So that's your total weight. Answer is option number 3. Okay? All right, let's take a look at question number 8. Question 8 reads, in the diagram of circle A shown below, chords CD and EF intersect at G, and chords CE and FD are drawn. Okay? Which statement is not always true? So 3 statements here are true, and 1 is false. So we have to determine which one is false, okay? All right. One thing you want to note in problems like this is if you have a pair of corresponding angles, we call that AA. If a pair of corresponding angles of 2 triangles are congruent, then the triangles are similar. Okay? That's one of the similarity postulates. Now, one thing you want to remember, quick reminder concerning circles, inscribed angles, and intersected arcs, is that in a circle, 2 inscribed angles like you have here with the same intersected arc are congruent. Okay? Alright, so these are the steps we're going to use to solve this problem. First of all, we're going to mark the congruent parts of this triangle, of the 2 triangles we have here based on what we have, based on the situation. Then we're going to determine what similarity or congruency postulate or theorems are applicable to these 2 triangles here. And then we are going to eliminate the option that is not consistent with whatever conclusion we came up with in step number 2. Okay? Now, just a real quick review. When you're proving congruency, you have SSS, SAS, ASA, AAS, and HL. All right? Don't not forget that when you're dealing with congruency, S represents congruent sides. Now, in similarity, we have 3. It can either be AA, SSS, or SAS. Now, in similarity, S does not mean that the sides are congruent. It means that the sides, corresponding sides, are in proportion. Okay? So you have to be really careful about what the S's mean in similarity and what they mean in congruency. All right, so let's take a look at this situation right here. If you look at these 2 triangles, I can make a quick conclusion. I can conclude that angle C is congruent to angle F. How do we know that? Angle C is congruent to angle F because you have 2 inscribed angles with the same intercepted arc. All right, so we can write a 2-column proof for this. Let's go ahead and write that real quick, our statement and reason. So, so the statement that I made is that angle C is congruent to angle F. Angle C is congruent to angle F. And the reason is because we have 2 inscribed angles with the same intercepted arc. Okay, inscribed angles with the same intercepted arcs are congruent. All right, so this is A. What does this A mean? Well, this A means that we have 2 congruent angles. All right, so we're looking at either SAS, ASA, AAS, AA or SAS. All right, so let's see what else can we deduce from this triangle. Wait, take a look. CGE and FGD. What do you notice about those two angles? What do you notice about this angle right here and this angle right here? They are congruent. Do you know the reason for their congruency? Let's write it down first. So angle CGE our next statement, angle CGE is congruent to angle, what did we say? FGD. And what's the reason? Vertical angles. What do we know about vertical angles? Vertical angles are congruent. So we have another A, pair of congruent angles. All right. So in this problem, that's basically all the conclusions we can draw. We just have an A situation. Two triangles where corresponding angles are congruent. A pair of corresponding angles are congruent. Now, if you look at this chart we have here, what can we conclude? Can we say these two triangles, triangles CEG and FDG, are they congruent or similar? Just simply look for AA. There you go, right there, similarity. Okay, so based on the AA similarity postulate, we can conclude that triangle CEG is congruent to triangle, is similar, sorry, to triangle FGD. Okay, so triangle CEG is similar to triangle FDG. All right, so our reason is by the AA angle similarity postulate. Okay, so what can we conclude so far? That option number 4 is good. Okay, but we're looking for the statement that's not true, so cancel that out. Now, CEG and FGD. CEG and FDG. What do we know about these angles right here? What do we know about corresponding angles of two similar triangles? Corresponding angles of similar triangles are congruent. Okay, so we know for a certainty that angle CEG is congruent to triangle FDG. The reason is because corresponding angles of similar triangles are congruent. So let's write that down. Corresponding angles of similar triangles. All right, corresponding angles of similar triangles are congruent. So option 2 is correct. So let's cross that out. We're looking for what's not true, okay? So be careful with that. Now, let's look at option 3. It says CE over EG. Let's look at that. CE over EG. CE over EG is equal to FD over DG. That's a ratio of corresponding sides. What do we know about ratio of corresponding sides of similar triangles? Ratio of corresponding sides of similar triangles are equal. Okay, so that's the whole idea of similarity. So we also know for a certainty that CE over EG is equal to FD over DG. This is true because the ratio of corresponding sides of not just any triangle, but ratio of corresponding sides of a similar triangle. What do we know about the ratio of corresponding sides of a similar triangle? They are equal. All right. This is always true, so it's not an answer. By elimination, we can see that option 1 is the answer. Now remember we talked about this earlier, that the S in similarity represents proportionality and the S in congruency represents congruency. Now, did we say that these two triangles are congruent? The answer is no. We said that they are similar. So statements concerning congruency of sides are not always applicable to similarity. Okay? So it could be true, but it's not always true. That's what the question asked for. Okay? So whenever you have two congruent sides, it's not a conclusion you can always draw from similarity, but you can always draw that conclusion for congruency. But this is not a congruent case, so option 1 is not always true. All right, let's take a look at question number 9. It reads, which equation represents a line that is perpendicular to the line represented by 2x minus y equals 7? Now, one tip for problems like this concerning parallel and perpendicular lines, given the equations, is that to compare slopes, given the equations of lines, it's best to write the equation in slope-intercept form. Okay, slope-intercept form, that's the safest way of accurately and efficiently determining the slope. There are other ways, but it's safer to just put it in y equals mx plus b form. Now the steps are as follows. First, we're going to write the given equation in y equals mx plus b form. Notice it is in standard form. We're going to change it into slope-intercept form. And then we're going to find the negative reciprocal of the slope. Why are we looking for negative reciprocal? Because if two lines are perpendicular, the slope of the first line is a negative reciprocal of the perpendicular line. All right? So after finding the negative reciprocal of this line, we have the slope of a line perpendicular to it. And then we're going to determine the slopes of these four lines, whichever is a negative reciprocal of the slope of this line. The answer we got in step 2, that will be our answer. Okay? All right, so let's look for the slope of this line. So we have 2x minus y equals 7. So let's get y by itself. So it's in slope-intercept form. You subtract 2x from both sides. And then you have negative y equals negative 2x plus 7. And then you go ahead and divide every single term by negative 1. Well, you can multiply by negative 1, you achieve the same result. So you get y equals 2x minus 7. Now, the slope of this line is 2. What is the slope of a line perpendicular to this line? You do the negative reciprocal of 2, so it's negative 1/2. Okay? Now, which of these lines has a slope of negative 1/2? That is our answer. Okay? So remember y equals mx plus b. The coefficient of x is your m. So in this case, option 1, m is negative 1/2. Option 2, m is 1/2. Option 3, m is negative 2. Option 4, m is 2. So which one is our answer? Our answer is option number 1, because it has a slope that is a negative reciprocal of the slope of this line, which is 2. Okay, so answer is option number 1. All right, let's take a look at problem number 10, the last one in this review installment. It reads, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? Now, if you carry a polygon onto itself, you basically ended up with what you started with, okay? Identical shapes. Now, one thing you want to note is that when you rotate a regular polygon by the measure of its central angle, that rotation carries the polygon onto itself. All right? Just to illustrate, let's take a look at this example here. We have a four-sided regular polygon known as a quadrilateral. Okay? Now, what is the measure of the central angle of a polygon? Now, this is the measure of a central angle right here. Since there are four sides and a full circle is 360 degrees, that angle right there, let's call it theta, is going to be 360 degrees divided by 4. Okay, and that yields 90 degrees. Now the central angle here is 90. Now, what do you think happens if I rotate this square by the measure of its central angle 90 degrees? So let me go ahead and show what happens to you. Give you a real quick visual here. So I'm going to rotate it 90 degrees, which is a quarter of a circle. There you go, 90 degrees rotation. What just happened is basically identical to what it was before. Okay, so that's what this point here is stating. If you rotate a regular polygon by its central angle, it carries it onto itself. Basically, this vertex ends up in that vertex, this one moves on to the next one, this moves to the next one, and that moves to the next one, and you end up with the same shape that you started with. Okay, this applies to all regular polygons. So what this problem is asking, let's follow the steps. We're going to determine the number of sides of each polygon. Use the number of sides to find the measure of each central angle as we did for this example. Whichever central angle is 45 degrees, that is our answer. Okay, so in this problem, what we're looking for in essence is the measure of the central angle that is equal to 45 degrees. Okay, all right, so for octagon, we have 8 sides. Decagon, we have 10 sides. Hexagon, we have 6. Pentagon, we have 5. Okay, so for option number 1, the central angle is going to be full circle 360 divided by 8. And then for option 2, the central angle will be 360 divided by 10. And then for option 3, the central angle will be 360 divided by 6. Option 4 is 360 divided by 5. Okay? Alright, so let's do option 1. 8 goes into 36 4 times, remainder 40. 8 goes into 45 times. Voila! That is exactly what we want. The central angle of an octagon is 45 degrees, which means if you rotate this octagon by 45 degrees, you're going to end up with exactly what you started with. So our answer is option number 1. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. If you have any questions about this tutorial or any questions on the Geometry Common Core Regents exam, just place a question in the comment section below and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to the remainder of this review series, and also don't forget to check out our interactive practice test. You take multiple release test questions to really sharpen your skills for the upcoming Regents exam. Thanks again for watching and have a wonderful day.